Okay, so so the first thing I want to discuss is basically the different type of operation generally we do with sets. Okay, so for example, when we have bunch of sets, then we can take the union, we can take the intersection, or maybe we can take the difference, or we can talk about the complement of a set with respect to some universal set. So I'll go through all the concept quickly. So okay, so
Sir,
yes.
sir, I have a doubt in practice assignment 2.1, week 2, in the
Okay,
sixth
okay,
question.
okay, I'll come to that. Wait. Yeah, so I'll come to that. So what is your doubt? Like in week?
Week 2, practice assignment 2.1, sixth question.
Okay, I'll come to that. Okay, let me discuss few things related to week 1. So once I come to week 2, we'll discuss that question.
Okay, sir.
Okay. Okay, so so the first thing I want to discuss is basically the set union. Okay, so suppose you have two sets. Suppose you have, let's say you have two sets. Okay, so the first thing is like, as you know, the set. So set is basically, it's a collection of some kind of objects, some well-defined objects. So suppose you have two sets. Let's say you have two set X, and you have another set Y. Okay, so what do we mean by the union of these two sets? So we have one set X and another set Y. So the union of two set is nothing but you just need to combine the elements of X and Y. Okay, so X union Y is nothing, you just need to form a set, and the elements are basically the elements of X as well as the elements of Y. So that is what we mean by X union Y. So the union is nothing, it's basically you need to combine. Please mute yourself. Combine the elements of X and Y. Okay, you just need to combine the elements of X and Y, and mathematically we write this as X union Y as all the elements such that A either is in X or A in Y. So if either A is in X or A is in Y, then A should be a member of X union Y. Okay, so for example, let's take X to be this set 1, 2, 7, 9, and Y is nothing but 2, 8, 5, 3. So we have two sets X and Y, and both. So what is the cardinality of X?
4.
4, correct. And similarly, the cardinality of Y is also 4, right? So both the set contains 4 elements. So what is X union Y?
1, 2, 3, 5, 7, 8, and 9.
Correct. So you just need to take all the elements of X. We just need to combine all the elements of X and as well as all the elements of Y. So So we just need to write 1, 2, 7, 9. Okay. And so basically we have covered all the elements of X. So next thing we need to cover all the elements of Y. So 2. So the first element, as you can see, this is 2, and we have already written down 2 in our union. So we don't need to write it down again. Okay. So the next thing is 8. 8 is not here, so we need to write 8 here. And the next thing is 5. The last one is 3. So what is the cardinality of X union Y?
8. 8, sir.
Are you sure?
No, sir. 7.
7, sir.
7. As you can see, so the thing is, as you can see, there is a common element in X and Y. So we just need to count it once. Okay. We don't have to count it twice. Okay. So one thing is sure, that one thing from here you can say that the cardinality of X union Y is not equal to the cardinality of X plus the cardinality of Y. So as you can see here, the cardinality of X and Y is 7, and cardinality of X is 4 and Y is 4. Okay. So now this is a pretty easy. So both X and Y, these are finite set, and it's really easy to deal with. Suppose I have one more set. Suppose my X is set up all natural number. Okay, so let's say my set is set up all natural. 1, 2, 3, 4, 5, and so on. Okay. And my another set Y is set up on even natural number. Okay, 0, 2, 4, 6, 8, and so on. So now can you tell me what is X union Y?
X, sir.
Sorry?
X union Y equals X, sir.
Correct. So basically, as you can see, all the elements that are in Y, they are already in X. Okay. So then I don't have to consider the element of Y again in the union. I just need to consider all the elements of X, because X already contains Y. Okay. So I don't have to count. I don't have to consider the elements of Y twice. Okay. Because all the elements of Y are already inside X. Okay. So X union Y is nothing but 0, 1, 2, 3, all the natural numbers. Okay. So next, take an example. Okay, now let's take this set X. So X is what? X is all the elements, all the elements such that A is a natural number. Correct? A is a natural number and A is less than 20. Okay, and at the same time A is congruent to 0 mod 5. This is my X, right? And what is my Y? Y is the collection of natural number such that now A is less than equal to 30 and A is congruent to 0 mod 10. So now can one of you tell me what is X union Y?
Y, sir.
Why?
Because
So
I
X
think
actually,
Sorry?
X should be the answer, right? Because any number that is divisible by 5 will also be
No,
divisible
there
by
are there. So the thing is, so as you can see, there are two conditions on the elements of. There are two different conditions
Okay,
on the
yeah.
elements of X as well as on the elements of Y. So here, as you can see, A is all. So here A is less than 20, right? So first thing you need to notice that we are putting three conditions on the elements of X and as well as on the elements of Y. So in X, the first condition is the element should be a natural number. This is my first condition. Okay. And the second condition is it has to be a number which is less than 20, right? And the third condition is it has to be a number such that it is divisible by 5. Okay. So the third condition is it has to be divisible by 5. Okay. And in the second set, if you see, second set, the same, the first condition, like the first condition is A has to be a natural number, but the second condition is slightly different. So the natural number, that number, whatever you are taking, that has to be less than 30. Okay. And the third condition is also different. That is, A should be congruent to 0 mod 10. So before computing X union Y, first we need to compute what is X, right? We need to write down all the elements of X and we need to write down all the elements of Y. Then only we can explicitly write X union Y. Okay. So my first question is, what is X?
5, 10, 15.
5, 10, 15 on teacher.
What about
10, 15.
what about 0?
0, 5, 10, 15, and 20.
Correct. So the thing is, what we have to take in X, we have to consider all the elements, all the elements which are less than 20 and as well as divisible by 5. Okay, that is precisely the definition of X. So we need to start with the first natural number, that is 0. Okay, so as you can see, 0 is congruent to 0 mod, right? And as well
0
as,
is natural number start from 1 to
no. So the thing is, okay, so you need natural number. Okay, have you watched the lecture, like because so
Week
basically
1.
yeah, week 1. So throughout week 1 we have assumed that 0 is a natural number. So the 0, so the first thing is 0. Okay, so 0 is divisible by divisible by 5, and as well as 0 is less than 20. Okay, so the first element of X is 0. Then the next thing we should check 1. Okay, so 1 is certainly is a natural number. So the first condition holds, right? And the second condition is A has to be less than 20. So 1 is clearly less than 20. The second condition holds, but the third condition doesn't hold. The third condition says that A has to be congruent to 0 mod 4, but 1 is not congruent to 0 mod 5. Okay, so 1 cannot be element of X. And similarly, you can check that 2 is also not a member of X, 3 is also not a member of X, and 4 is also not a member of X. Okay, so if you check with 5, then 5 will satisfy these three conditions. So the next element is 5. Then you can check 10, 15. What about 20? Whether 20 is a member of X?
No.
Why?
No, sir. Because it is less than
Less than
20.
20.
it is not
Correct.
less than 20.
Correct. Because correct. So 20 will not satisfy this condition. Okay, if I take A to be 20, then 20 is not less than 20. Okay, so 20 doesn't satisfy the second condition. So I cannot take 20 as a element of X. So my X is 0, 5, 10, 15. Okay, this is my X. And what about Y?
0,
Why?
10, 20.
Yeah,
0,
0,
10,
10, 20.
20.
0,
10, 20, and 30.
correct. So as you can see, 30 is all. So here we are
That's
considering
equal also.
Yeah, so
Less than equal.
let me write it properly. So this is A is less than equal to 30. Okay, so now I know what are the elements of X, and as well as I know what are the elements of Y. Now I can easily compute what is X union Y. Okay, so now I can compute what is X union Y. So it's nothing but 0, 5,
10, 15,
10, 15,
20,
20, and 30, right? so it's always, so when some kind of expression is given instead of this set x, so here actually we are representing all the elements of x with bunch of conditions. So when some condition is given instead of the elements, so first thing what you need to do, you need to find out all the elements of the set x. Okay. And similarly, you need to find out all the elements of y, then you can easily compute x in n. Okay. Okay, so the next thing is intersection. So intersection is, so when you have two set x and y, so intersection is basically, it's a set which contains all the elements which are common to x and y. So you need to consider all the elements which are in x and as well as in y. Okay, so x intersection y is basically elements. You need to consider all the elements which are common to x and y. So mathematically we can write this as a such that a is in x and a is in y. So a should be in x as well as a should be in y. Okay, so let's go back and see whatever example we have already discussed. Let's compute the intersection for these examples. So in this example, so this is now so this is my set x and this is my set y, right? So what is now x intersection y?
2, sir.
So x, so by the definition, say x intersection y is basically all the elements which are common to both the sets. So now let's start with 1. Okay, so 1 is in x but 1 is not in y. Okay, so that means 1 is not common to both x and y. Okay, so then 1 cannot be an element of x intersection 1. And next element is 2. So as you can see, 2 is an element of x, and at the same time 2 is also an element of y. So then 2 is a member of x intersection y. And what about 7? 7 is in x but 7 is not in y. That means 7 is not common to both x and y. Okay, so that means 7 cannot be element of x intersection 1. And similarly you can check that 9 also cannot be an element of x intersection y. 8 also cannot be element of x intersection y. 5 is also cannot be element of x intersection y, because 5 is in y but 5 is not in x. Okay, and similarly 3 cannot be element of x intersection y. Okay, so x intersection y is nothing but it's 2. Is it clear?
Yes, sir.
Yeah.
So what about, so here, so the next example is this one. So this is the second example that we have already discussed, but we have discussed about union of sets. So for this example,
So in this example, sir, y set will become the intersection mostly.
correct, because see, as you can, so if you see all the elements of y, they are already inside x, right? So that means all the elements of y are common to x as well as y. Okay, so x intersection y is nothing but 0, 2, 4, 6, 8. So basically in this case, x intersection y is all the even natural numbers. And what about this one? So
Sir, in this 10 will become the intersection.
common, yeah. So as you can see, it's clear that
0,
10.
10, sir.
Oh, sorry, yeah,
Zero.
correct.
Sorry,
Zero,
sir,
also.
zero and 10,
Zero.
yes.
So 10 is there in X, and as well as 10 is there inside Y. And similarly, you can see 0 is inside X, as well as 0 is inside Y. Okay. So X intersection Y is nothing but 0 and 10. Okay. Okay, so for example, let's take one more example. So suppose X is set up, so X is set of rational number. Set of all set of all rational number, and Y is set of all irrational number. So then what you can say about X intersection Y?
Zero, sir.
Nothing, 0. Null set. Null set, sir.
Empty set, sir.
Empty set. It see, this cannot be 0, because see, 0 is a rational number, right?
Yes,
0,
sir.
0 is a rational number. 0 is inside X, but 0 is not a irrational number. 0 is not inside Y. Okay, since 0 is inside X, but it is not inside Y, that means 0 cannot be a member of X intersection Y, because 0 is not common to both the sides. 0 is only inside X, it's not inside Y. Okay, so that means 0 cannot be an element of X intersection Y. Okay, so to be more precisely, so if you pick a real number, it has to be either rational or irrational. It cannot be both. Okay, so there is no real number which is both rational and irrational. Okay, so that's why this X intersection Y is nothing. It's an empty set. Okay, there is no such number which is both rational and irrational. Okay, can you please mute? Okay, so so this is the empty set. So
Sorry to interrupt. I'm actually confused with the mod concept, sir. Will you explain once again? Because I thought 0 mod 5 is equal to 0. And I didn't understand how come 5, 15 and 20 come.
So you are talking about this one, right? This example.
Yes, sir.
Yeah. So so what is the issue here? So you don't, so you are facing issue with the elements of how actually
So she wants to understand the concept of mod, sir.
Yes,
okay.
sir.
Yeah. So
Because if we take an example like 25 mod 3, the answer would be 1, like which is the remainder of the
correct,
division.
correct,
So
correct.
similar to that, if you see 0 by 5, which is 0 mod 5, shouldn't that be equal to 0? How come 5, 10, 15 came into the came as an element into the
No,
set X?
so 0 mod 5 is 0, right?
Yes, sir.
So you are correct. Whatever you are saying is correct.
Yes, sir.
So 0 mod 5 is 0. So that means 0 is congruent to 0 mod 5, right?
Yes, sir.
So that means 0 satisfies all the condition that is given on the set X, right?
Yes, sir.
So that means 0 has to be an element of X.
What about the rest numbers, 5, 10, 15? How come it satisfies 0 mod 5 condition?
No, this is not 0 mod 5. This is A mod 5. A is congruent to 0 mod 5.
Yes, sir. A is
Yeah.
congruent to 0 mod 5. And the answer for 0 mod 5 is equal to 0. So 5
okay,
should...
okay. So let me go back and do it from the beginning. So what do we, so basically, again, so let me recall that there are 3 conditions given on the set X, right? So
yes, sir.
so this is the first condition, this is the second condition, and this is the third condition. Okay.
Yes, sir.
So basically I will start with the first natural number, right? That is 0.
Yes,
Correct?
sir.
So I need to check all the three properties, whether 0 satisfies all the three property or not. That I need to check. Okay, if 0 satisfies all these three property, then I can say that 0 is inside X, right?
No, sir, I understood 0 is an element of X, set X, but I didn't understand how come 5, 10, 15 is an element in the X, sir.
Yeah, I'll come to that. Okay, so you agree that 0 satisfy all these three conditions, and
Yes,
do you agree that one doesn't satisfy all these three conditions? Like,
yes, sir.
not
I
all,
agree.
like one of these three conditions.
Yes,
So
sir.
you agree. So let's take now 5. So 5 satisfy this condition. 5 is a natural number, right?
Yes, sir.
And the second condition is 5 is less than 20, right?
Yes, sir. Yeah, yes, sir.
So the third condition is you need to check whether 5 is congruent to 0 mod 5. So what is the remainder you will get if you divide 5 with 5?
Okay, okay, I understood, sir. Okay.
Okay, so again you can easily say that 6 is not element of X, right?
Yes, sir.
Then 7 also is not element of X, and you can say again you can start checking with 10. What
Yes,
about 10? 10 is a natural number, right?
Yes, sir.
10 is less than 20. And what you will get if you divide 10 with 5?
2.
No. I'm saying
No, I'm
remainder.
sorry. Yeah, 0. Yeah.
So here we are taking remainder. Okay. So this is 0, right?
Yes, sir.
Similarly, you can check like 15 is also element of X. So this part is clear, right?
Yes, sir.
Okay, fine. Okay, so now so for this case, X intersection Y is empty. Okay, so the set of irrational number, and Y is set of X is set of rational number, and Y is set of irrational number, and in this case X intersection Y is an empty set. And so generally we represent empty set with this notation, or also sometimes we represent with this notation. Okay, both the things, they represent the same thing, that is empty set. Okay. So the next property, the crucial property, is set difference. Okay.
Sir?
Yes, please.
Union of X and Y will be real number, right?
Correct. Yes. X union Y is R.
Yeah.
Because
Sir, excuse me, sir.
So one doubt in that 0 mod 5, sir. Sir, should we not write it like if A divides if A bar B, then A mod B equal to 0. Should we not write B mod A equal to 0? Should we not write like that, sir?
No, sorry, can you repeat? It's not clear to me.
If A bar B, then
what is A bar B?
Sir, I could not get that, sir. 1 minute, sir. Should we not write it like that? B mod A equal to 0, sir. That is, let us take that B is equal to 0, 5, 10, 15, and A is equal to something, sir.
So no, you want me to write like this: A
instead mod, of
A mod 5 is 0.
Oh yes, sir. Is that a correct manner, sir? Am I right, sir?
No. See, whatever you are saying is correct, but whatever I have written is also correct.
Okay. Oh, okay, sir. I was a little bit confused, sir.
So these two things are same. Okay. So whatever you are saying and whatever I have written, they are same.
Okay, sir. Okay, sir. Thank you, sir.
Yeah.
Sorry for interrupting, sir.
Okay. So this say A is congruent to 0 mod 5 is basically same thing as saying as 5 divides A. Okay, so when you say, when basically you say A is congruent to, so A is congruent to B mod 5, this is same as 5 divide a minus b. So in this case, my b is 0, right? So in this case, my b is 0. So this thing is same as 5 divides a minus 0, which is a. Okay, so next is set difference. And okay, so set difference, or maybe you can use some other terminology, that's set subtraction. Okay, so the thing is, suppose you have two set x and y. Okay, these are two sets, it is given, and x minus y, that is the difference, x difference y, or some different notation also. Most of the time you will see that in most of the book they use this notation. Okay, the second. So x difference y is nothing but all the elements of x, that are not in y. Okay, so this set x difference y is basically all the elements that are in x but not in y. So here we need to consider all the elements of x. So in x difference y, we just need to consider all the elements of x that are not in y. Okay, so mathematically how we can write a such that a is in x and a is not in y. Okay. So for example, take this set 1, 2, 3, and y is 2, 3, 7, 9, 11. Okay, so here what is x difference y?
1.
So what basically we are searching for? We are searching for the elements of x that are not in y, right? So for x difference y, we need to search for all such elements that are in x but not in y. So let's go to let's check one by one. So the first element is 1. So 1 is in x, right? Clearly 1 is in x, but as you can see, 1 is not in y. 1 is not in y. That means 1 satisfies this condition, the elements that are in x but not in y. So 1 is in this set. And what about 2? 2 is in x, but at the same time 2 is also in y. So then 2 is not, I cannot say that 2 is a member of x difference y, because 2 doesn't satisfy the condition. Okay, 2 is in x but it's not in y, that this condition is not true. 2 is in x as well as 2 is in y. So 2 cannot be element of x difference y. And similarly you can check that 3 is in x as well as 3 is also in y. Okay, similarly 3 cannot be element of x difference y. So x difference y is nothing but 1.
Sir, I have a doubt, sir. Can I ask?
Yes, please.
Sir, previous you say a congruent a mod 5 is equal similar to a 5 divided by a.
5 divided.
Then I put the value of a, sir, equal to 0. Then I get infinitive, sir, not 0, sir.
Why?
Sir, 5 divided by 0 is
5 divide 0 or not?
5 divided by 0.
5 divide 0 or no?
0, sir.
So if 5 divide 0, then how you will get infinity? You will get 0, right? Remainder 0 you will get, right?
Oh, yes, sir.
Yeah.
Thank you, sir.
Yes. So 5 is basically what? 5 times 0 is 0. That means 5 divides 0. Okay. When you say A divides B, if you can write B as a multiple of A, okay, so A times some C. So when I can say that 5 divides 0, when I can write 0 as a multiple of 5. So here I can write 0 as a multiple of 5. 0 is nothing but 5 times 0. Okay.
Oh, okay, sir.
Okay. Okay, so what about this one? X. So what? So in this case, what is X difference Y? So for this example, what is X difference Y?
It can be empty set, sir.
Why?
Empty sets. Empty set.
Why?
No, sir. It's rational numbers.
All rational numbers.
Please, like I'm getting a lot of noises. So
Sir, all the rational numbers, sir.
correct. So the answer is actually all the rational numbers. See all. So all the elements of X are actually not in Y. Okay, if you pick any element from the set X, that element is not in Y, because all the elements of X are rational number. Okay, so a rational number cannot lie inside Y. Okay, because Y consists of all irrational numbers. So all the elements of X are not in Y. So that means X difference Y. That means X difference Y is precisely X, because all the elements of X are not in Y. Oh. Okay, so fine. So far this all these operations are clear, right? Any doubt?
Nothing, sir.
No, sir.
Okay, fine.
No, sir.
Okay,
No,
so
sir.
the next thing I want to do is relation. Okay. So the next thing I want to do is relation. So relation. Okay, so before going into types of relation, so can one of you tell me what is relation?
So relation is the process in which there are some inputs and we can gain some.
No, don't tell me some vague thing. You tell me the definition. What is relation? So you start with some set, then define it. Okay. What is the mathematical definition of relation?
Relation between two or more sets.
No, you are
subset.
Yes. Yeah. Carry on. Whatever you are saying, I guess is correct. Please continue.
Relation is can be defined between two sets.
Where one set is a subset of another set.
No. You tell me the definition.
Is relation a subset of a set according to some kind of a condition?
Again, you are saying some kind of condition. What is that condition? Say it clearly. Like whatever most of you are saying is completely wrong. Okay, so try to say whenever you are trying to define something, define it properly. What is the proper definition? Give me a proper definition of relation.
How the two sets are related to each other.
Again, you are saying the same thing, right? There is no meaning. There is no, whatever you said, it has no meaning. It completely meaningless, whatever you are saying.
So
relation is a subset of a Cartesian product we can combine two
Correct,
sets
correct.
Cartesian
So
product.
yeah, so you start, so that is the problem. Like again, you are saying, suppose you have two sets. Suppose you have two sets A and B. Okay, you start with this. Okay, you can't define relation without set. Okay, so first you have to start with some set. Okay, suppose you have two set A and B. Okay, suppose you have two sets A and B. So relation from relation from A to B is nothing but it's a subset of A times B. Okay, so relation and you know how to define this Cartesian product, right? So it's basically this is nothing but contains all the possible tuples, where the first element of the tuples come from A and the second element of this tuple come from. Okay, so A is in A and B is in B. Okay, so this is how we define Cartesian product. So relation is nothing but it's a subset of A cross. Okay, so suppose suppose A is 1, 2, 3 and B is set glass and pen. Okay, so my question is whether this R my question is whether R is a relation. Whether R is a relation.
No, sir. No, sir.
Correct. Correct.
No, sir.
Not a subset of Cartesian product.
Correct. So as you can see, R is not a subset of Cartesian. R is not a subset of A cross B because of this third element, right? So as you can see, glass. So if you go back and check the definition, the first element of the tuple should be a member of A. So here this glass is not a member of A, it's a member of B. So this element is not inside A cross B. That's why R cannot be a subset of A cross B. So that's why R is not a relation from A to B. Okay. So what about this one? Whether I can say okay, sorry, this is 1, 2, 7, 5. Whether this R whether this is a relation from A to B.
Yes, sir.
Yes. Yes, sir.
So it's clear, right? So it's a subset of A cross B. So that's why R is a relation from set A to B. When so sometimes A and B can be equal. Okay, sometimes A and B can be equal. So if A and B are equal, in that case, I'll simply say that R is a relation on the set A. Okay, instead of saying that R is a relation from A to A, I'll simply say that R is a relation on the set A. So instead of saying it, let me repeat, instead of saying it that R is a relation from A to A, I'll just simply say that R is a relation on the set A. That's okay. When when A and B are equal. Okay. Okay, so from now on, actually I want to define this equivalence relation and reflexive relation. So not equivalence relation. First, I want to define this identity relation and reflexive relation, symmetry relation, and transitive relation. And I guess one more relation is there, some anti-symmetry relation. So for all these relation, so the first condition I need that A and B are equal. Okay, so from now on, my this set A and B are equal. Okay, so that means R is a relation on the set A. Okay, so suppose okay, so now I want to define identity relation.
Sir,
Yes, please.
can I say R is a relation on the set B in the same situation?
Yes, you can say that when A is equals to B. Okay, so you can say that also R is a relation on the set B. But okay, I simply want to use A. Okay, so basically it's a terminology. Okay, so don't get confused with this A and B. So here A and B are equal. You can use B instead of A, but okay, so it's better if all of us will use this A. So suppose R is a relation. So suppose R is a relation on a set A. So when I can say that R is a okay, so one more thing, like someone is saying that if it would be helpful if we can do some questions so that we are prepared for qualifier, similar question to qualifier or something. No, certainly I'm not going to do similar question to qualifier. Okay, so then there will be no point of the exam. Okay, so my question is whether the way I'm going, whether it is fine, or do you want me to solve more questions instead of I'll pick some, instead of discussing the concept, I'll pick bunch of question and I'll start solving it.
Sir, I would request if you can mix the story like you're giving, but do one or two more questions, so it will help us clear the concept.
No, so now what I am doing, I am basically, now what I am doing, I am defining something. After that, I am solving some problem, right?
Yeah, that's better, sir.
This is
better.
fine, sir.
Okay.
Yeah.
So what you're doing is fine, sir.
Okay, fine. Okay, fine. So
Fine, sir.
So what actually, so the thing is I cannot cover all the concept, right? So I cannot cover all the 4 week concepts. So what I have planned something like some few topics from week 1, few topics from week 2, and some few topics from week 3 and week 4 that I'm planning to cover as much as possible. Okay, that is, so my plan is I'll give you some background behind the theory, and after that I'll solve some 1-2 questions related to that. So,
is there any mock test for the revision? Mock test, sir?
I guess no, because there was a mock test for quiz too, but I don't know whether for this there is any mock test. I don't think.
attempt doesn't have, sir.
Yeah.
Okay, sir, no. Thank you.
So okay, so suppose R is.
Excuse me, sir. Sir, one doubt, sir. Sir, in regarding sets, sir, can you explain me the difference between the subset and the proper subset, sir?
Okay, I'll come to that. Yeah. Just once. Okay, so just remind me in the end. In the sense when I'll jump from week 1 to week 2. Before that, you just remind me. Okay, I'll at that time I'll explain it. Okay, so so when I can say that R is a, suppose R is a relation on a set A, so I can say that R is a identity relation. I can say that R is an identity relation if and only if R is nothing but this set A comma A, where A is in. If R is precisely this set, if R is precisely this set, the set whatever I have defined here, then I can say that R is a identity relation on A. Okay. Otherwise, R is not a identity relation. If R is this, if R contains all the diagonal elements, precisely all the diagonal elements, apart from that, nothing else. Okay. Apart from the diagonal element, R doesn't contain anything else, then you say that R is a identity relation on the set A. Okay. So, so my first question is, okay, so let's take A to be 5, 7, 13 and 11. So whether whether R is a identity relation on A or not.
Yes.
Yes, sir.
Why?
I think no, sir. No, because the other elements 13 and 11, they are not in the relation.
Correct. So R is, as you can see, R is not, it's not an identity relation. Okay, so R is not an identity relation. Why?
There is not elements.
Because see, it says A comma A should be a member of R for all A in A. Okay, so for all A in A comma A should be inside R. Okay, so as you can see, 5. So okay, so the first element of A is 5. So 5 comma 5 is in R. Okay, so this this hold for the first element 5. What about second? 7 comma 7 is also.
Sir, if there had been an 11 comma 11 and 13 comma 13, then it will be an identity relation.
Yes, correct. So this condition holds for 7. But this condition doesn't hold for 13, because 13 comma 13 is not in R. Okay, and similarly 11 comma 11 is also not in R. So this condition doesn't hold for 13 and as well as for 11. So that's why R is not a identity relation. Okay.
So in any of the infinity sets, we would not be able to identify whether it's an identity relation or not.
What do you mean by infinity set? Can you give me some example? Which set you are talking
Maybe
about?
set of all natural numbers.
Oh, okay,
or some set of relation numbers, something wherein we don't know the end, or we don't know how many are there.
No,
how many means
so
cardinality is not.
Yeah, that is fine. So here A is set of all natural number. I am asking what is the relation? What is the relation on that set A? Okay, you must have, so when you have a set, then you must have to know whether to check about identity relation, you must have an identity relation on that set, right? Oh, sorry, you must have some relation on that set, right? If you don't have a relation, then how you are going to check whether that is an identity relation? I'll come to that. I'll give an example. So okay, let me first complete for this one. What about this relation? Suppose you take this one. 5, 5, 7, 7, 13, 13, 11, 11, and 530. So whether R is a identity relation on A?
No, sir.
No, sir.
Yes, sir.
No, sir.
Because
No, sir,
because you have all the diagonal elements, okay, but apart from diagonal
Some elements are
elements,
present.
you have an extra element. Okay, we don't want this kind of elements in our identity relation. Okay, so in identity relation should only contain all the diagonal elements. But here, apart from diagonal elements, you have one more extra element. So we don't want this one here. So that's why this is R is not an identity relation. Okay. What about if I remove this one? If I remove this one, whether this is a identity relation?
Now it's identity.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Because this set precisely contains all the diagonal elements. Okay, so now this is a identity relation. Okay.
I have a doubt.
Hmm.
So if here 5, 5, 7, 7, 13, 13, 11, 11. Only these elements are identical elements. So if we have every elements like 5, 7, 5, 13, 5, 11, then 7, 13, 7, 11. Like this, if we go on, then what is that?
That is not an identity relation. Okay. That is what I can say. Okay, if you include one more element apart from these elements, then that whatever new set you will get, that will not be a identity relation.
So what that one?
Sorry.
Yeah, that's only a reflexive relation, sir.
No, I'm not. See, don't ask me what is reflexive. I'll come to that. Okay, now I'm talking about identity relation. Okay, now stick to the identity relation. Okay.
Okay.
Yes. Okay, so this is a identity. So this relation R is a identity relation. Suppose now my set A is nothing but the set of all natural number 0, 1, 2, 3. So the next question is whether this relation R, suppose I have a relation R on this set A. So here this set A is nothing but it's the set of all natural number. Whether this 1, 1, 2, 2, 3, 3, whether this is a identity relation on N?
No, sir.
No, sir.
Why?
Because it doesn't have 0,
Identity
You have to include 0, 0 also.
Yes, correct. So because you have 0 here, but you don't have 0, 0. Okay. So in this case, R is not an identity, it's identity relation on the set of natural. Okay. So it doesn't matter whether whether your set is infinite or finite. You just need to check the condition. Okay, if your relation contains all the diagonal element, precisely all the diagonal element, apart from that nothing else, then you say that your relation is a identity relation. Okay.
A cross A is a relation.
Sorry?
A cross A is a relation.
A cross A
is whether a relation or not.
What is the definition of relation?
Subset of a cross product.
So in this case, whether it is a subset of cross product A cross A?
Yes, sir.
So then if A cross A, so A cross A is a subset of A cross A, right?
Yes, sir.
So then it is a relation. So yeah.
Okay.
So what do you mean by diagonal elements?
Diagonal elements means A comma A. Okay, that is actually the diagonal elements. Okay. See this. So this thing, this A comma A, when both the things are same, actually both the components are same, at that time we say it as diagonal elements. Means this 5, 5, 5,
Okay, sir.
5, 7, 7, 13, 13. These are diagonal elements. But 5, 7 is not a diagonal element. Okay, this is not a diagonal element because here 5 and 7 they are different.
Okay, sir. Thank you.
Yeah, thanks. So okay, so the next thing is reflexive relation. So reflexive, so suppose R is a relation. Suppose R is a relation. I can say that R is reflexive relation if and only if R contains the identity relation. Not contains. Contains is not correct one. If and only if identity relation is a subset of R. If a relation, if the identity relation on the set A is a subset of R, then we can say that R is a reflexive relation. Okay. So for example, take R equal to 1, 2. Sorry, not R. A equal to 1, 2. Okay. So my question is whether this is a 1, 1, 2, 2, 1, 2, and 2, 1. Whether this is a reflexive relation on the set A?
Yes, sir.
Why?
Yes, sir.
Why?
Because it contains the identity relation, sir.
Because identity relation is a subset of R. Since identity relation is a subset of R, then I can say that R is a reflexive relation. What if I remove this one?
Even then it's a reflexive.
Still it contains identity relation is a subset of R, right? And what if I remove this one instead of 1, 2? If I remove this one, then it is not a reflexive because 2, 2 is not in R, right? So that's why I is not a subset of R. Okay. So that's so when your reflexive relation, so reflexive relation is precisely when it contains when the identity relation is a subset of R. Okay. So the concept of reflexive relation is clear, right?
Yes, sir.
Okay.
Yes, sir.
So the next one is symmetry relation. So symmetry relation. So R is a symmetry relation. I can say that R is a symmetry relation on A.
Sir, one question.
Sorry?
Can I ask? One question can I ask? So for the reflexive relation, how many sets can become like 1, 1, 1, 2, and 2, 3?
You are not clear to me. Like I am not unable to hear you.
So can you hear me now?
No.
Okay. Can you hear now?
No, some kind of different noise is coming along with your voice.
Okay, 1 minute. I'll switch off the fan. Can you hear me now?
Am I facing the problem or
No,
others?
we are also facing actually.
We are also
Yeah,
facing the
we are
problem,
also.
sir.
Okay, can I? So how many cardinality will come for 1, 2?
How many cardinality?
Like how many different
Elements.
sets can come? Like 1, 2, 1, 1, 1, 2, and 2, 1. 3 sets can come.
Three?
3 sets can come for 1, 2.
What do you mean by 3 sets can come for one?
Like you have typed right 1, 2.
I have, so this is a relation, right? 1, 1, 1, 2, 2, 1. This is a relation.
Yes,
And
yes.
I just want to know that whether this relation is a reflexive relation or not. That's all.
Okay.
Hmm.
So for 1, 2, 3 sets can come. That is what I was. That is my question.
No, 3 sets means what? Like I still don't understand what you mean. 3 sets can come. You have a relation and you want to check whether that relation is a reflexive relation or not. That is what you want. You have only one set. You cannot have more than 10 set. Sorry, more than one set. You want to know whether a relation is given. You want to know whether
So
that
the elements are 1, 1, 1, 2, and 2, 1.
yes,
So,
these are 3 elements. Yeah.
Okay, so 3 elements can come in 1, 2, right?
No, you are asking some different question, I guess. See, this is a relation. This relation has 3 elements. If you add one more element, you will get a different relation. You will not get the same
But
relation.
the set is only 1, 2, right? Set is only 1, 2.
Set.
So in that,
yes, set is in a set A, you can have lot of relations, right? So relation is nothing but it's a subset of A cross A. So if you take if you take a subset, then that will become a relation on the set A. Okay, so instead of R, I can take one more relation R, which is 1, 1, 1, 2. This is also a relation, but this relation and this relation, they are different. Okay.
yes.
Yeah, so you can have multiple relations. That is fine.
No. For identity relation, it can come only 3 elements, like 1, 1, 1, 2, and 2, 1. Just for my understanding, I am asking.
No. Identity relation, for identity relation, you can have only 2 elements.
Sorry, not identity. For reflexive.
No. Reflexive relation, you can have multiple. Like there are so many things. So
how many combinations can come for 1, 2?
How many combinations?
Sir, like how many elements? How many subsets?
How many subsets?
Sir, he's asking
how many
like
subsets? Like how many elements?
Okay.
Sir, in relation, how many this one will come? This 1, 1 and 2, 2. Yes. For this, how many subsets will come?
I think he is asking A cross A.
Subhashish,
What will be
for
the
your
cardinality?
question, the answer is it depends on the kind of relation you are evaluating.
Yes.
The set is 1, 2. But now, if you would like to know how many combination of this kind of sets would be coming, that purely depends on the type of relation you are evaluating. Assume that in case our relation is able to evaluate and then give me this kind of 3 sets, then in these pairs, can I say that relation as an identity relation, or does it satisfy the reflexive relation, is what we are trying to understand here.
Also, I just want to add one point. He also asking like if we have 2 elements in a particular set, then how much possible pairs will be there? So if you have 2 elements, so four elements like 1, 1, 1, 2 will get in the reflective. If we have 3 elements, then we will get 6 pairs, like 8 pairs.
If you have 3 elements, then probably at max you can get 9 pair. Yeah, 3 elements.
Yeah.
No, so what now? What actually now you are going into? You are talking about. Now you are talking. What are the possible subsets of A cross A?
Actually, he is asking for cardinality.
What was doubt? I think is he's asking that in identical set we can get only one. If 1, 2 is
What is identical set?
Sorry, sir.
A cross A. A cross A.
A cross A, it's huge.
Identical relation.
A cross A will satisfy all the thing, all the three relations like this symmetry. It will be symmetry, transitive, and reflexive. So A cross A is you are taking the is more or less you are taking the full set. Okay, so that will satisfy all the conditions. So relation is a subset of A cross A. So what you do, you pick a subset of A cross A and you check whether that subset is a reflexive relation or not. That you have to check one by one.
Sir, if A is equal to 1, 2, and in identical relation, we will get 1, 1, and
okay,
2,
we'll come to this later. Okay.
So please move on, sir.
Yeah.
Please.
Okay, so
Sir, can you repeat symmetric relation?
Sorry?
Can you repeat symmetric relation, sir? Because certainly I don't understand.
No, I can't hear you. That is the problem. You are saying something about symmetry relation. I am going to discuss it now, yes, right? I have not discussed it till now. I will discuss it now.
Okay, sir. Okay, sir.
Yeah. So I'll come. Whatever you are saying is not. Still, I'm not sure what was your question. We'll come to that question later. Okay. Okay, suppose you have a relation R on some set A. Okay, so so you want to know whether that relation is a symmetry or not. So for that, what you need to do, you need to check this condition. If this is in R, if this is in R, if this A comma B is in R, then if B comma A is also in R, okay, for all A comma B in R, then we can say that R is a symmetry relation. That basically it's saying if in this relation, it's saying that if in this relation, if A is related to R, A is related to B, then B has to be also related to A. If this is true for all the elements of R, then you can say that R is a symmetry relation. Okay. So, so suppose I'm going to take the same set A comma 2. My question is whether this is a symmetry relation or not.
No, sir.
No, sir. No,
So,
sir.
So
No,
what we need to check? We need to check that if A comma B is in R, then this should imply that B comma A is also in R. Okay. So as you can see for this first tuple 1 comma 1 is in R. If I flip it, then I will get 1 comma 1. Okay, that is also in R. So this condition is true for the first element. Okay, and what about 1 comma 2? If I flip it, what I will get 2 comma 1, right? But 2 comma 1 is not in R. Okay, so that's why I can say that R is not a symmetry relation. Okay, so what about this one? Let's say, what about this relation? Whatever relation I have written here, whether this is a symmetry relation or not.
Yes, sir, symmetric, sir.
Because this relation has 3 elements. So let's start with the first element 1 comma 1. If I flip it, then I will get 1 comma 1, and 1 comma 1 is element of R. And similarly, the second element is 1 comma 2. If I flip it, I will get 2 comma 1, and 2 comma 1 you can say you can see that it is inside R. And similarly, if I flip 2 comma 1, then I will get 1 comma 2. which is inside R. Okay, so if I flip all the elements of R and if I land inside R, then I can say that R is a symmetric relation. If I flip all the elements of R and after that also I can land inside R, then I can say that my relation R is a reflexive, not reflexive, symmetric relation. Okay. So the next.
Excuse me, sir.
Yes.
Sir, can you just scroll upwards, sir? You have written some conditions regarding symmetric relation, sir. If A for all, what's that, sir? For all.
Hello. Hello.
Hello, can you hear me, sir?
Yes.
Sir, you have written some conditions in the first line of the symmetric relation, sir. Can I see that, sir? Can you scroll a little bit upwards, sir? 1 minute, sir. Sir.
Symmetry relation here. So symmetry relation started from.
Yes, sir. Thank you, sir.
Yes.
Sir, I have a doubt.
Yes.
So if 1, 2 is a element, then if 2 is 2, 1 is symmetric element, right?
No, for the symmetry relation, if to say that R is symmetry relation, for that you have to check if 1, 2 is there, then 2, 1 should also be inside R. Otherwise, you can't say that is a relation, symmetry relation.
So can you give me one more example?
Okay, for example, let's take, so let's say A is equal to 1, 2, 3. Now can you tell me whether R is a symmetry relation or not? Whoever asked this question.
No, sir.
No, sir. Because
okay, someone asked.
No, sir.
Why? Whoever asked me to repeat this. So I want you to answer this question. Yeah. So why this is not symmetry relation?
Because the element 1, 1 does not have 2, 3 means.
I understand what you are saying. So the thing is, as you can see, if I flip 1, 1, then I will get 1, 1, right? And 1, 1 is inside R. Okay, so this element is fine. Next is 2, 1, 2. If I flip it, then what I will get? I will get 2, 1, which is inside R. So this is fine. Okay. Now the problem is this one, 2, 3. If I flip 2, 3, then what I will get?
3, 2.
But 3, 2 is not inside R, right?
Yes.
That means R is not a symmetry relation. What is the definition of symmetry relation? It says that if A, B is in R, then B, A should also be in R. But here, as you can see in this relation, 2, 3 is in R, but 3, 2 is not in R. That's why it's not a symmetry relation. Clear?
Yes, sir. Sir, so if 1, 2, 3 is a set, so in that we should have for a symmetric relation, we should have 1, 1, 2, 2, 3, 3. Means whatever the possible combinations and the symmetric of that also it should be there inside it.
Yes, correct.
Okay.
Sir, please explain.
Sorry?
Anti-symmetric relation, sir, and asymmetric relation.
No, so the thing is, okay, so the first thing is you are wasting your time. Okay, let me tell you. Okay, because I'm going to do that and you are doing it multiple times, that you explain this. I'll come to, as I said, I'll come to that one by one. You are wasting your time by repeating the same thing again and again. Okay.
Yes, sir.
Sir, I have one doubt. Can you just
Yes.
give the difference between reflexive and symmetric for the same one, 1, 2, and 3? Like the same example.
This one you are saying.
Yes. Like 1, 2, 3. What will come for the reflexive?
Yeah. So this is. So do you think this is a reflexive relation? So what is the condition of reflexive relation? When I can say that R is reflexive?
So
what is the definition? What is the definition I gave for reflexive relation?
So it should be on the set A.
It should be
on the set A.
No, that is no. I gave some definition. Can you recall the definition? What I said when I can say that R is a reflexive relation if it contains the identity relation, right? If identity relation is a subset of R, okay, then I can say that R is reflexive. So what is the identity relation on this set A? What is I?
The collection of identity set.
Whoever asked this question, I want him to answer. Okay, what is I?
1, 1, 2, 2, 3, 3.
So now do you think I is a subset of R?
Yes.
So do you think I is a subset of R? Why?
So both identity and reflexive are same. That's what you're saying.
No. My question is whether you try to answer my question. My question is whether I is a subset of R.
Yeah, that is a condition. Right?
No,
yeah,
that is my question. My question is whether I is a subset of R. This is I, right? This is I, right?
Yes.
This is R. I have written both the sets. So my question is whether I is a subset of R.
No, it is not a subset of
So
R.
then if I is not a subset of R, then that basically imply that R is not reflexive.
Okay, sir. So identity and reflexive both are same. That means identity.
No. Identity and reflexive are not same. I have already discussed. They are different. Okay. If a relation contains identity relation, then you say that R is reflexive. Okay. Identity relation is different. I'll suggest you please go and check whatever I have discussed regarding identity relation.
Yes, sir. Yes, sir. I will check it. Please continue.
So suppose R is a relation on A, when I can say that R is transitive if A comma B is inside R and B comma C is inside R. This should imply that A comma C is in R. Then I can say that then I can say that A comma C. If A comma B is in R and B comma C is in R, if this should imply that A comma C is in R, then I can say that R is a transitive relation. So for example, you take this whatever example I have written here. Let's say A is 1, 2, 3, and R is 1, 1, 1, 2, 2, 3, and 2, 1. Whether this is a transitive relation or not?
No, sir.
Why?
A comma.
So let's.
Should be there. Yeah, or 1, 3 should be there.
So for that for transitive relation, what I need to check? If A comma B is in R and B comma C is in R, then I need to check whether A comma C is in R. If this is true for all the possible pairs, then I can say that R is transitive relation. For example, this is my A comma B, and this is my B comma C, right? Because here 1 and 1, they are same. So if I take A comma C, but I will get 1 comma 2. But 1 comma 2 is not inside R, right? That means R is not a transitive relation. I don't have to go and check for other elements. Okay, if it doesn't satisfy for two tuples, then from there itself I can say that R is not transitive relation. Okay. So for example, let's say this one. Let me take one more example. 1 comma 1, 1 comma 2, and okay, sorry, I guess I made mistake here.
Yes, sir. Yes.
Because
it is a transitive relation.
No. It's I guess it's not a transitive relation, but I made a mistake. So here A comma C is basically what? 1 comma 2.
1
right?
comma 2 exists. Yes.
1 comma 2 is inside R, right? Now if you take these two tuples, so here A comma B and B comma C. Now if you take A comma C, what you will get? 1 comma 3. 1 comma 3 is not inside R. Okay. So from here itself, you can say that R is not transitive, right? So let's take this example, 1 comma 1, 1 comma 2. My question is whether this is a transitive relation on A.
Yes, sir, transitive.
Yes, sir, transitive.
Transitive, because if you take A comma B and B comma C, then what I will get? If you
A comma C is here.
So A comma C is nothing. It's basically 1 comma 2.
1 comma 2.
And which is inside R. That means R is a transitive relation. Okay. So basically you need to check for all the possible pairs. Okay, you need to check for all the possible pairs which are of this form: A comma B, B comma C. Okay. So
Excuse me, sir.
Please.
I have one doubt, sir. In 1 comma 1 is an identical element. There is also 1 comma 1 in A comma B, B comma C. So it's a transitive, sir. It's also contain transitive.
So sorry, you are giving me some other relation. What is that relation? 1 comma 1?
Not it's identical element 1 comma 1. It's also contain 1 comma 1. It's also can have 1 comma 1. A comma B equal to 1 comma 1. B comma C equal to 1 comma 1. So we can A comma C also 1 comma 1. So it's a transitive.
So what is your relation? Can you tell me the relation? What is your relation? What is R?
That is 1 comma 1, 2 comma 2, 2 comma 2, 3 comma 3.
This is your relation.
Yes, sir.
Yeah, then this is transitive, right? Because see what basically definition says: if A comma B and B comma C is in R, then only I need to check whether A comma C is in R or not. Okay, but here I don't have this kind of pair, right? Because this, if you take this element, this is in the form of A comma B, right? But this is not in the form of B comma C, right? This is not in the form of B comma C. This is also not in the form of B comma C, because here B is 1, but here you have something different, 2. Okay.
Yeah.
So I don't have to check that condition. That is vacuously true, because when I don't have this kind of pairs, A comma B and B comma C, then I don't have to check it vacuously. It's true automatically. Okay. So here I don't have any elements which are of the form A comma B and B comma C. That's why it is automatically true that R is a transitive relation. Okay. So this is a, so you can say that this is a transitive relation. Okay.
So sir, for if we have A comma B and we don't have B comma C, then we don't have to check for A comma C and like
correct. When you don't have B,
and
then
if we have the pair like we have A comma B and we have B comma C, and if there is not A comma C, then it is not transitive, right?
Yes. If you have such kind of pair, then only you need to check. Otherwise, no need to check.
Thank you.
Okay. Okay, so let me go to week 2. So week 2, I want to discuss two things. So the main thing is basically how we can compute so equation of a line which passes through some point and it's perpendicular to some other line. Okay, so two things I want to discuss in week 2. I'll come to, like, if I have time, then I'll come to function. So so the first thing I want to discuss how I can get equation. So what is the general form of a line? Equation of the general form of a line. Can
y equal to mx plus c.
Y equal to mx plus. This is not general, but it's basically you call it, I guess, slope intercept form. Okay, so this represents
ax plus by
plus by
X plus by plus c is equal to 0.
Yeah, so
General
general equation probably is ax plus by plus c equal to 0, but it doesn't matter. This is also represent the equation of line. So this is the slope of the line, and this is
y-intercept.
your y-intercept. Okay. So what I want to do, I want to find the equation of a line, equation of a perpendicular line passing through a point. So what is my aim? So what is given? One line is given. Okay, so this is given. This line is given. What? And one point is given. Okay, so this point is given. What I want to know, I want to find this line which passes through this point, as well as this is perpendicular to this line, ax plus by plus c. So I want to find the equation of this line L1. So any idea how I can find the equation of the line L1?
The help.
Sorry.
The help of theta we find.
Help of
Theta.
Theta.
Tan theta. Angle of insulation.
We can find the slope of the line.
Or m into m1 equal to -1.
There is a formula, sir, for this.
Not formula. It's more or less it's easy. So what is the thing you need to know? So you know. So this.
First we have to find the slope, sir.
Yes. So let's say this is the slope of M1 is the slope of L1, right? And I know the slope of this line, which is M2, and I know L1 and this line, they are perpendicular, right? So that means I know M1 times M2 is what?
-1.
-1.
And from here I can get the value of M1, right? Yeah. I can get the value of M1. So from there I can get the value of this line L1, and also I know that this L1 passes through this point P. So now can you find the equation of L1?
Yes, sir.
Because you
Yes,
know
sir.
because you know this line L1 has slope M1 and it passes through the point P. So then automatically from there you can get the equation of L1. So suppose let's take this question. So you need to find the equation.
Sir, it might be like that y minus y1 is equal to m into x minus x1, right, sir?
Yeah. Let me do an example. The line x minus 2y plus 3 equal to 0 and passes through minus 1 comma 2. So we need to find a perpendicular, we need to find the equation of a line which is perpendicular to this line, and that perpendicular line also passes through minus 1 comma 2. So how I can do that? So something is given, this line is given. So equation of this line is x minus 2y plus 3, which is 0. And one more thing is given, that perpendicular line, it passes through this point minus 1 comma 2, right? So first thing what I need to do, I need to find the slope of L1. What is the slope of L1?
Minus 1 by minus 2, that's 1 by 2.
So slope
1 by 2.
1 by 2. So slope of L1 is 1 by 2. Okay. So once you know the slope, then you are done, right?
Yes.
Because you know, so now you know the slope of the line is half and it passes through minus 1 comma 2. So from there you can easily find out the equation of the line. What is that? The equation.
How did we take out the slope of L1?
So that is so this is perpendicular, right? L1 is perpendicular to this line. What is the slope of this line? X minus 2y plus 3 equal to 0.
Sir, L1 will be minus
b by a.
No, what is the slope of this line? X minus 2y.
Minus b by 2a.
That slope is 1 by 2.
No, slope of this line is 1 by 2.
1 by 2.
Of
Okay.
x.
Okay, let me come. This is basically what? X plus 3, which is 2y. That means y is plus 3 by 2. So that means slope is your half. Okay. So the slope of this line is half, right? Slope of this line is half. Okay. So that means
in that case we have to divide the whatever the equation is given in the question.
So that means so slope of L1, okay, times slope of this line is minus 1. The slope of L1, which is M1, times half is minus 1, right?
Okay, yeah.
So that means M1 is
minus 2.
Minus 2. Okay, so this is incorrect. Right? Now it's clear how I'm getting the slope of L1 to be
Yes, sir. Yes, sir.
minus 2. Okay. So now you just need to apply this formula like y minus y naught, which is minus 1. Sorry, not minus 1. This is 2 into slope, which is minus 2 times x minus x naught, which minus 2. Okay, so
no, sir, minus 1, sir.
Minus 1, sir.
Yeah, sorry. So this is nothing but, so the equation of the line is y minus 2 into 2 times x plus 1. Okay, so this is how. So when when it is given that one line is perpendicular to some other line and it passes through points, so the main idea is you need to find out the slope of the line L1. And how you can do it? By applying these formulas, because you know if two lines are perpendicular, then the product of their slope is minus 1. Okay. Okay, so the next thing is I need to find distance between a point and a line. Okay, suppose one line is given, let's say ax plus by plus c equal to 0. Okay, so one line is given and I have a point somewhere here. So let's say this is my point, x comma 1, y comma x1, y1. And what I want to compute this distance. Okay, this perpendicular distance between this point and this line. Okay, so can one of you tell me what is the formula for distance?
Yes, sir. D is equal to mod in mod ax1 plus by1 plus c divided by under root a square plus b square.
Yes.
Yes.
Okay, so if I apply this formula, suppose I want to compute the distance between this point P, minus 1 comma 2, and this line x minus 2y plus 3. What will be the distance between P and this line x minus 2y plus 3? How I can compute it? P is what? P is minus 1 comma 2, right? So if I apply the formula, what I should get? A if I apply the formula, what I should get? So I want to compute the distance. So someone already said, right, the distance between this point and a line. So what should I get if I apply that formula?
1 minute.
Minus 1.
Minus 1.
Minus 4.
Minus 4. Right, because 2 times minus 2, which is minus 4, plus
3. Plus 3.
Divided by 1 square plus 2 square, right?
Yeah, yes.
So then this is nothing but this distance is nothing but this is minus 5 plus 3, which is 2 by 5, right?
Okay.
No, sir, under root 5.
Root 5, sir.
Okay, sorry, yeah, square root. Correct. So okay, so someone is asking what about distance formula, section formula? Okay, so the thing is, okay, so first thing is let me remind you, it's not possible for me to cover all the things. Okay, so I have planned for few things, and that is what I am doing. Okay, so it's impossible for me to cover each and everything from week 1 to week 4. So that is certainly not possible.
Excuse me, sir.
One doubt.
I have a doubt in previous question, sir. Slope and line passing. First, we find the slope of line L1 is a M2, sir, and a value of 1 by 2.
No. See, slope of L1. No, but this line L1, right?
Okay.
L1 is perpendicular to this line.
Yeah.
Right? This line. That means slope of L1 times slope of x minus 2y plus 3 is what?
-1.
-1. Now, what is the slope of this line? X minus 2y plus 3.
1/2.
1/2. That means slope of L1 times 1/2 is -1, right?
Yeah.
That means slope of L1 is what?
-2.
That is what we got, right?
Okay.
Not -2. So once you know the slope of -2, the slope of L1 is -2, then you can easily compute
Formula, general equation.
Yes. Okay, so and next thing is suppose you have two lines. Suppose you have two lines which are parallel. Okay, so suppose you have two lines. So this is one line, and another line is. So how? So suppose you have two lines. So how you can compute the distance between two lines?
Mod of C1 minus C2 by under root.
Yeah, so basically you have some formula for that. So when two parallel lines are given, you can easily compute the distance between these two parallel lines by using this formula, C1 minus C2 modulus divided by 1 plus m square. Since you have two parallel lines, both the slopes of these two lines are equal. So, and another way how you can compute, you pick, otherwise you what you do, you take, if you don't remember this formula, what you do, suppose this is your line and this is another line. What you do, you take any point from this line, y equal to mx plus c1. You take any arbitrary point, and from that point you compute the perpendicular distance. Okay, so from there also you can get the distance between two parallel lines. Okay. Suppose you have these lines 2x plus, let's say 3, and one more line which is 3x plus 5. So if I apply this formula, then what I should get? What is C1 here?
Sir, we can't apply, sir, because sir m is not equal, sir.
Correct. So here m is 2 and here m is 3. So these two lines are not parallel. Okay, so that means I cannot apply this formula. Okay, I can apply this formula when I have two parallel lines. Okay, so if instead of 3, if I have 2, then these two lines are parallel. Then only I can find out distance between these two lines, which is 3 minus 5 divided by 1 plus 4, which is 2 by root 5. Okay. Okay, so
sir, I have a doubt in formula. Sir, in formula, don't we use in upon under root a square plus b square?
Sorry?
Sir, the formula for two parallel lines, so the formula is mod C1 minus C2. Sir, in upon, don't we use a square plus b square?
No, actually, see, you have a slope, right? So you can actually write down the slope, I guess, in terms of AB. Okay, so if you convert that formula, okay, so generally, I guess you can write, so if you have a line like this, ax plus by plus c, then the slope is basically minus, I guess, minus b by a, right?
A by b.
A by b. Okay, so So actually, whatever expression you will get in terms of AB, so you can convert it into M. Okay, so if you convert whatever you are saying, if you convert that thing by putting this one, okay, so eventually you will get this one. Okay, so these are the thing what I wanted to discuss in week 3. Okay, so the next thing is probably I'm going to discuss in week 3 is quadratic function, and I'll quickly say a few things about quadratic function. So
one doubt in week 2, sir.
Yes, please.
So 1 minute, sir.
You have some question or
doubt, sir? Doubt regarding the question, sir.
Yeah, I'll come to that later. Okay. So
no, sir. Doubt regarding the discussed question, sir. Sir, can you hear me?
Yes.
Sir, regarding the equation of the line perpendicular to a line, you have solved the answer that is minus 5 2 by root 5, sir. Can you explain that, sir? 2 by root 5.
This one.
That one, sir. How minus 1 came there, sir?
Okay, so again, I guess I have explained it maybe 2-3 times.
Sorry, sir, I could not get that, sir. The only doubt I have is how minus 1 came there, sir.
Which one?
Minus 1, minus 4, like that, sir. How minus 1 came there, sir?
Actually, this video is available in YouTube, so you can watch it twice. You can just take backward and watch it. Yeah. So we don't have time. It's already 8:30, right? 8:30 or 8:40.
Okay,
so
okay.
Better, yeah.
Okay, so quadratic function is nothing but it's a degree 2 polynomial, right? So there are 2 or maybe 1, 2, 3 things which are very crucial about quadratic function, and that is what mostly you need when you solve a question related to quadratic function. One is axis of symmetry, okay, and whether this quadratic function is open downward and upward, and what can be the range of that quadratic function. Okay, these are the 3 things which are really crucial when you solve a question related to quadratic function. Okay, so first thing is quadratic function is something which is of this form, right? X square px plus c, and there is one more condition. What is that condition?
A should not equal to
Correct. So a should not be equal to 0. If a is 0, then basically we'll, instead of quadratic, we will get a linear polynomial. Okay, so this is a quadratic function, and sometimes if we draw the graph, then that we call that graph as a parabola. So vaguely quadratic function. So there are 2 types of quadratic function. One which opens upward, and another one which opens downward. So when this quadratic function, or let's say parabola, is opens downward, if I put under what condition that parabola is opens upward?
A greater than 0, sir.
Leading coefficient -1.
So if a is, so if you have some specific doubt, give me some time. I'll try to explain your doubt, like some other doubt. I'll give some time in the end, and I'll try to solve all these things. So don't worry about that. But before that, let me complete this thing. I'll take maybe few more minutes to complete all these things. Okay. So if a is greater than 0, okay, so if a is greater than 0, then the parabola is open upward. And if a is less than 0,
downward.
Then the parabola is
Downward.
open downward. And one more interesting thing about this parabola is this parabola has some axis of symmetry. Okay. So this line, so whatever this line is a axis of symmetry for this parabola. And how we can get the axis of symmetry of the parabola? The equation of this line is nothing but x equal to minus b by 2a, right? So one more thing is, once I know the axis of symmetry, then I can get the vertex, right? Once I know the axis of symmetry, then I can get the vertex, okay, which is minus b by 2a and f of minus b by 2. So this will give me the vertex of the parabola, okay. And similarly for this case also, this I can get this axis of symmetry, which is basically minus b by 2a. And similarly, if I substitute this point also, I can get by the same logic minus b by 2a. Now my question is, what is the range of this first one? So parabola, so suppose this is my parabola, ax square plus bx plus c, and here a is greater than 0. So whatever this is, this represent, it's a function from set of all real number to set of all r. My question is, what is the range?
0 to infinity, sir.
Why? Why?
0 to positive infinity.
Yes, 0 to not 0, positive infinity is yes.
Positive infinity.
1 to plus 1 to positive infinity.
No, wrong. So okay, so my
function.
Okay, so one thing, okay, please mute, I'm getting some noise. So one thing is, this parabola opens upward, right? Since this is opens upward, it has a minimum value, right? Correct or not? This parabola opens upward, so this has a minimum value, right? And how I can get the minimum value of this parabola?
If a is less than 0.
No, at what point this parabola will give me the
minus b upon 2a vertex.
So the minimum value, what is the minimum value of this parabola? The minimum value is f of minus b by 2a, right? This is the minimum value of parabola. Okay, this is the minimum value of the parabola. Okay. This is the minimum value that a parabola can take of this form where a is greater than 0. Okay, so this is the minimum value of the parabola. That means the range is f of minus b by 2a to infinity, because this parabola opens upward. It will take all the value which are above this thing, which is f of minus b by 2a. Is it clear how we are getting the range of the parabola?
Sir, what if it is downward?
That I'll come, but
that is the second meaning. It's a vertex. So the vertex is also similar as the minimum range for the parabola.
that will be similar. It will, so this will get flipped. Okay. So instead of infinity, you will get minus infinity.
Okay, got it.
So okay. So for example, you take this function f of x is equal to 2x square plus 3x plus 1. Okay. So now here a is positive, right? A is positive. So that means this parabola is open upward, right? So what is the minimum value of this parabola?
-3/4. -3/4.
-3/4.
Minimum value of the parabola -3/4. No, the minimum value is f of -3/4. Okay. See, there is a difference. See, this point. So this point will give me the minimum value, and the y coordinate of this point will give me the minimum value. And what is the
y coordinate?
Y coordinate. So the coordinate is -b/2a, f of -b/2.
Yes, sir.
So this one will give me the minimum value of the parabola, and the minimum value is f of -3/4, which is okay. Let's say someone already said this is probably -1. Okay.
-1/8.
Okay, whatever it is, -1/8. Okay, let's say this is, you can calculate what is that value. So the minimum value of this parabola is -1/8. That means the range of the parabola will be -1/8 to infinity. Okay.
So what if the vertex of the parabola isn't touching the y-intercept?
Vertex of the parabola is not touching the...
What if the vertex of the parabola is not touching the y-intercept?
It doesn't matter.
I mean, it has 0 root, suppose.
It doesn't matter. You have a vertex, right? Here, we are not using the property that we are not using the fact that whether the vertex touches the x-axis or the parabola crosses the x-axis. It doesn't matter. What we are finding here, we are only finding the vertex, right? That is what we are doing here, right? We don't care whether the parabola crosses this x-axis, or it is above x-axis, or it is below x-axis. That certainly we don't care. Only thing we need to find here, we need to find the coordinate of the vertex, and the y coordinate of the vertex will give us the minimum value of the parabola. Okay.
And sir, what is the range of x intercept?
Is the range of x intercept means what? You have to find out the roots. For that, you need to find out the roots of the quadratic case.
Oh, okay.
To find the, see, there is no range, right? You have hardly, you can have 2 x intercept. Okay. For that, you need to find the roots. You can have range of a function. Okay. So similarly, if you have a parabola, where a is less than 0, okay, so in that case, what you can do? So in that case, your parabola is what? Open. If a is less than 0, then how the parabola will be?
Downward.
Downward open.
Okay. That means it has a maximum value, right? Let me draw it slightly different. Every time you are thinking that x, it's this y-axis is its axis of symmetry. So then it will have a maximum value, and sorry, it will have a maximum value. And how you can get the maximum value? By computing the vertex by the same
-b/2.
So the y coordinate of the vertex will give you the maximum value of the parabola. Okay, that means the range of the parabola is nothing but -infinity to f of -b/2. So because here the maximum value is basically f of -b/2, and anything which is less than that will also be inside the range of the parabola. Okay. Okay, so I guess yeah, so these are the things which are crucial for you to solve any problem related to parabola, because that is what you need to find most of the cases. In most of the time, you need to find somehow you need to find the vertex, and after once you get the vertex, actually you can solve most of the problem related to parabola. Okay, so the next thing is so probably the last thing, how I can draw a graph of a polynomial. Okay. How I can draw a graph polynomial. Okay. Suppose some polynomial is given. Let's say this is my polynomial, right? So how I can draw the graph of this polynomial? So the first thing is you have to find out the roots of the polynomial. Okay, which is very easy for this one. What are the roots of this polynomial?
2, 3, and 5.
Roots are 2, 3, and 5. But you have to you have to, as well as so apart from only finding the roots, you have to find out the multiplicity of the roots. So what is the multiplicity of 2 here?
2.
2, right? This is 2, which is even. Okay. And what is the multiplicity of 3 here?
1.
1, which is odd. Okay. And similarly, what is the multiplicity of 5?
1.
It's 1, and that is odd. Right? So so the next thing, what you need to do, you need to find out the y-intercept. What is y-intercept of this polynomial? What you need to do to find the y-intercept? In y-intercept, your x coordinate is 0, right?
Yes, sir. We need to put zeros in place of x.
Yeah, so the y-intercept is p of 0, which is 4 minus 3 minus 5, which is 60, right? That means my polynomial passes through this point, 0, 60. Okay, and the next thing is I have to check the end behavior, right? So one thing, if x tends to infinity, where this polynomial will go? If x tends to infinity, where this polynomial will go?
Infinity.
Correct. Because why? Because the degree of the polynomial is even, and as well as the coefficient. So what is the highest coefficient? Yes, the highest power of x, the coefficient of the highest power of x here is positive. Okay, so that means if x tends to infinity, then p of x also tends to infinity. Okay, so now we can easily compute the graph. So one thing we have, if x tends to infinity, then p of x tends to infinity. So now I can easily draw the graph of this polynomial. So what are the roots? Roots are 2, 3, 5. So one thing it says, as x goes to infinity, p of x goes to positive infinity. Okay, so in this direction, if you go in this direction, the value of p of x is positive. That means the graph will come from this side, from the above side of x-axis. Okay, this will come from this side, and it will come to 5, because 5 is a root of the polynomial. But but you don't know what will happen, whether this graph will cross this x-axis or it will reflect back from x-axis. For that, we need to check the multiplicity of 5, the root 5, which is odd. As you can see, the multiplicity of 5 is odd, right? If the since the multiplicity of 5 is odd, it will cross the x-axis, right? Again, it will cross the x-axis and it will come back to 3. But again, I don't know what will happen, whether it will cross this 0.3 or whether it will bounce back. For that, again, I have to go and check the multiplicity of 3. What is multiplicity of 3 here? It's odd. Again, it will cross the x-axis and again it will come back to 2. And the same thing applies here. I don't know what will happen at 2. For that, I have to go back and check the multiplicity of 2. What is the multiplicity of 2 here? It's even now. Then since the multiplicity of 2 is not odd, then it will bounce back. Okay, it will come like this and again it will bounce back like this. Okay, and this point is nothing, it's 0, 60. Okay, since the multiplicity of 2 is even, it will bounce back and it will go like this. So this will be the graph of the polynomial. So when you want to draw a graph, you have to make sure, first thing, so the most crucial thing is you need to know what are the roots and what are the multiplicity of these roots, and one more thing is the end behavior. Okay, once you know the end behavior and the multiplicity of polynomial, from there you can easily draw the graph of the polynomial. Okay.
I have here one question instead of 0, because it's an intercept of y which you took the 0, so it should not be a 4 or 2 because it's a bounce back from the x-axis.
Sorry, can you repeat? Like you are talking about this question, right?
Yeah, I'm talking about this. You took the 0, right? Y-intercept is 0.
0,16.
Yeah, 0,60. So it's a bounce back. It will not take a 2 or 4 because it's a bounce back from 2 and it will go up to 4 or 2.
No, sorry. So here 2 is odd, right? The multiplicity of 2 is even, right? So it will bounce back and it will cross the y-axis somewhere, right?
Yeah.
So to compute the point where this curve will cross the y-axis, for that we have computed this y-intercept, right?
Right.
So y-intercept is what? 60, right?
Okay.
So at x equal to 0, the value of polynomial is 60, right? So that is what we are getting here. So it will cross this point.
Okay, got it, sir. Thank you.
Yes.
How will I find y-intercept?
Sorry?
I won't disturb your flow. Y-intercept, how will find?
Y-intercept, right?
Yes, that's one.
So y-intercept. So y-intercept. What is the definition of y-intercept? It's basically the point where the graph crosses the y-axis, right?
Yeah.
That means in y-axis, your x value is 0, right?
Yeah.
So once you substitute x equal to 0 in your polynomial, okay. So what we have done here, we have substituted p. So we have calculated p of 0. What is p of 0? So if I substitute x equal to 0 in my polynomial, then I will get a value of y, right?
Yeah.
So that 0 and p of 0 is precisely your y-intercept.
Okay. Sir, how will you find the end behavior here? Because the leading coefficient is positive, so it tends to positive infinity or negative infinity, positive infinity and p of x.
So what is p? What is the leading term here in p of x? What is the leading term here? This is what?
X minus 2.
No, in p of x, what is the leading term? Highest. Like you have some highest degree of x.
X minus 2 whole square.
No, if you multiply, so you have, so from here you will get x square, right?
Yeah.
Here you have x, right?
Yeah.
Here you have x. So if you multiply x square with x and x, what you will get? X power 4, right?
Yeah.
Plus
Yeah.
some lower degree term.
Yeah, yeah.
Right. So now if x goes to infinity, then where x power 4 will go?
It also goes to infinity.
Infinity. So from here, so basically this term, this leading term, highest degree term, will give you the end behavior of the polynomial. Okay, since x goes to infinity, that's why if x goes to infinity, that's why x power 4 also goes to infinity. That's why your p of x will also goes towards infinity. So if instead of x power 4, you have minus x power 4. Okay, so if instead of x power 4, you have minus x power 4, then what will happen? Your x
minus infinity
is, then your minus x power 4 will go to minus infinity, and your p of x will go to minus
infinity.
Yes.
Yes.
Okay.
So could you please have one more example of the same concept?
Okay, so let me take one more example.
Can I give one equation?
Please. Yeah, what is that?
Yes, 1 minute. Yeah. N square by 1000.
N square by 1000.
Yeah.
N square.
Yes, sir. X square, let it be x square.
By 1000, yeah, it doesn't matter. 1000, it's basically.
And next is x.
Next is x.
Yeah, only x.
You have x square by 1000, right?
Yeah. The first factor is x square by 1000. I am telling the factorized form. And another is x, and another is x minus 5, x minus 10 plus 50.
X minus 5.
X minus 10.
X minus 10. Then
x. Only
x.
Plus 50. Yeah.
This is fine.
Yes, sir. Like above 1000, there is x square also.
You have plus 50.
Yes, sir.
No, then no, this you cannot draw the graph. Okay, then this is not possible. For that you have to find out the roots. Okay. So you need to find out the roots. It has to be of this form. Okay, the form that I have written above. Okay, so here I can easily find out the roots. Okay, so here I cannot easily find out the roots. I have to solve the equation, then I have to find out the roots. Okay. So if I remove this 50, then probably I can draw it. And what you need to do then, once you know the graph, you just add 50, right?
Okay, sir.
See, if you have a 50 here, okay, if I can draw the graph, of this function, then what I need to do, suppose this is the graph of this function p of x. Okay, what I need to do, I need to shift this one by 50, right? Then I'll get the graph of this one, let's say like this. Okay, so if I shift the graph by 50, then I will get the graph of new function, that is this one. Okay.
So actual question wasn't factorized actually.
No, what is that question actually?
Yeah, actual question is x square by 1000 and x to the power 3.
So in that question, whether they have asked you to draw the graph of this function, what is the main aim of that question? That is also matter, right? So in that question, whether they have asked you to draw the to find out the turning points, or maybe the graph of the function, whether they have asked you this type of things in that question.
But it is related to graph.
Yeah, that related to, but what is the ultimate aim? That is also matter, right?
How many, in positive axis, how many are there, like this type?
Okay, let me take some example. Let's say this is minus x minus 5 square, x minus x plus 3 square, and x plus 2. Okay, what are the roots of this polynomial?
5 minus 3 minus 2.
5 minus 3 minus 2. And the multiplicity of 5 is what?
2.
2, sir.
Even, right? No.
Yes, sir, even.
And
2.
multiplicity of minus 3 is even.
Even. Or even.
And multiplicity of minus 2 is
Odd.
odd. So what is the y-intercept of this polynomial? P of 0, right? To find out the y-intercept, we need to find P of 0, right? What is P of 0 here?
25 minus 25 into 9 into 2.
So this is 50, 450, right? Minus 450.
It is 25, right? Not minus 25.
No, you have a minus here, right? In the beginning, you have a minus here, right?
Yes, sir. Yes, sir.
Yeah. So the y-intercept is what? 0, comma, minus 450. Okay. Okay. Next thing is what? We need to find the end behavior. So what is the leading term here? This is x square. So this one x square, and this one also x square, and x. So 2 plus 2, 4, 5. So the first highest term is minus x to the power 5. Okay, and after that you will get some lower degree term. Okay, so we don't care about this lower degree term. The only thing that will give us the end behavior is the first highest degree term and its coefficient. Okay, so if x tends to infinity, then where minus x power 5 will go? It will also go towards, this will go towards minus infinity, right?
Yeah.
Yes, sir.
So that means P of x will also go towards minus infinity, right? So we know the end behavior. Okay. So now we are ready to draw the graph of this polynomial. Okay. So we have just a minute. Okay, so now we have 3 roots. So 5 minus 3 minus 2. Okay, one is minus 3 minus 2, and another one is 5. Okay. And you can see as x goes to infinity, P of x will go towards minus infinity, right? So that means if you go towards this, then the value of the polynomial is negative, is 2 less. Okay, so that means the graph will come from this side because the P of x is negative. If P of x is positive, then it will come from this side. But in this case, this P of x is negative. So for that, it has to come from this side. So it will come up to 5. Now we don't know whether it will cross this x-axis or whether it will bounce back. For that, what we need to do, we need to check the multiplicity of 5. What is multiplicity of 5? It's 2, right? It's even. So that means it will bounce back. Okay, and it will bounce back, and again it will cross this y-axis at this point 0 comma, because we have already computed the y-intercept 0 comma 50. Okay, then it will go to -2, and we don't know whether it will cross this -2 or whether it will bounce back. For that I have to check the multiplicity of -2. What is the multiplicity of minus?
That's odd.
-2, it's odd. Okay, that means it will cross the x-axis. Okay, so again it will cross the x-axis, and again it will come back to 3. And for that I have to know whether this will cross the x-axis or bounce back. For that I have to
bounce back.
Yeah, because the multiplicity of -3 is even. So that's why it will come and again bounce back like this. Okay, so as you can see here, you have two turning point, right? This is a turning point, and this is a turning point, and the graph will look like this. Okay, so this function, this polynomial has two turning points, and the graph, not two, I guess,
3 turning points.
3, not
3 turning points.
So
yeah.
4, sir. 4, sir. At
Yeah.
3, it is also another turning point.
So this
-3.
this is a turning point. This is a turning point. This is a turning point, and this is a turning. Okay, you have four turns. 1, 2, 3, 4 turns.
Thank you, sir.
Yeah, thanks. Okay, so any other doubt?
Sir, if it is coming with x3 or x4, 5, something like that, how it is?
Sorry?
Roots.
That doesn't matter. See, we don't care whether it's 5 or 7. Only thing we care whether it's even or odd, right? We are only, when you have odd, it will cross the x-axis, right? When you have even, it will bounce back. When you have even, it will bounce back. When you have odd, it will cross the x-axis. Okay, that's all. It doesn't matter whether it's 3 or it's 5 or it's 7. You just need to check whether these numbers are even or odd. If it is even, it will bounce back. If it is odd, it will cross the x-axis.
So if it is x4, 4 also, it is there also, it will behave like a even like how it is coming.
Yes, same. Some kind of see, we are drawing a vague picture, so there will be some. If you have x4, x square, it will bounce back like this maybe, and if it is x4, it will bounce back like this. So slightly difference is there, but certainly it will bounce back. Okay, any other doubt?
I have one general doubt, sir. These slides are available for Max.
Sorry.
In this class, slides are available in our Max portal.
No, once this is over, I'll send the portal team to upload it. Okay. In the portal. Okay.
There is an available, sir.
Sorry.
It's available. The slides.
Slides, no. Once this session will over, after that only I will send these slides to portal team.
Okay, sir.
Yeah.
So once again, will you tell the end behavior polynomial?
Yeah, that is what so I have explained here, right? The end.
So one doubt I have, sir.
No. Someone else asked, right? So what is the problem with the end behavior? So do you have any doubt here? Whatever I have explained here for this question.
No.
So then what is the problem with? So one thing is you have to find out the leading term of that polynomial, the highest
leading coefficient, sir.
Sir, I have a question.
So once you find out the leading coefficient, after that it's easy, right? You just need to check, see if the leading coefficient is x to the power 5 minus x to the 5, then if x goes towards infinity, then this will goes towards minus infinity. Okay, see, if that is the coefficient of the leading term is positive, then it will go towards plus infinity. If the coefficient of the leading term is negative, then it will go towards minus infinity. That's all. You have only two cases, right? So yeah.
One doubt I have.
Sir, I have
a question.
Mm-hmm.
So how we are getting that minus x to the power 5?
No, I am saying, so here if you multiply this polynomial here, if you multiply this polynomial, what you will get? You will get
X to the power 5.
minus x to the power 5 plus something with x to the power 4, okay, then plus something with x to the power 3 and so on, right? So this minus x to the power minus 5 is basically the leading term of this polynomial, and the coefficient of x to the power 5 here is negative, minus.
Okay, got it.
So one question, sir. So if equation is given like x to the power 2 divided by 10.
X to the power 2
divided by 10. And x minus 5.
What, plus or minus or what?
Like it is in a factorized form.
X to the power 10 into
x minus 5.
X minus 5.
X minus 10.
X minus 10.
Into x.
Into x. Man means x cube by 10.
Okay. Yeah.
Then
that's only.
No, what do you want me to do for that? This
for graph.
You try to draw, like I gave you to, I solved two questions, right? You try to.
Sir, can you mute centrally, sir?
No, I guess only one person is unmuted, so it's fine. Yeah, so you can try like the same thing. You have, say this is what? This is x minus 0 whole cube, right? So you
okay, sir, I got it, sir. Actually, I was confused. In question, it was given like x was given individually. So I thought like how it is possible that for a particular root, there can be a two behavior, like it can bounce back also, and it can also like
no. So see, so sometimes what happens, if you see in the question, you may see this type of question: x minus 2 into 2 minus x. For that, what you have to do, you have to club them together. So this 2 minus x is what? This is minus of x minus 2. Okay.
Yes.
And if you multiply both the things, you will get what? X minus 2 whole square. So you have to make sure you are clubbing all the things together. Then only you can draw the graph proper.
Okay, sir. That was only the doubt, sir. Thank you, sir.
Okay, fine.
Sir, I have a doubt.
So can I? So in June last there was a question. Consider a polynomial function. P of x is.
Sorry, you are not audible.
So now I am clear.
No, it's not. You are not audible. Sorry. Some different noise is coming along with your.
Sir, in the example there, you said x minus 0 to the whole cube. So what happens to the 10 which is below there, sir, as a denominator?
No, it doesn't matter. So the thing is what actually this, if you have a constant, then it will scale the graph. Okay, that's all. You will not change the graph. Okay, so if you have, so it's basically it will just scale the graph. That's all. Nothing else. So you will get a similar type of graph with some different scale. Okay. Instead of 10, if you have 1000 also, it doesn't matter. It simply it will scale the graph.
Okay, thanks, sir.
Yeah.
Sir, I have a question. What if we have graph of two polynomial equations
means functions. So how are we supposed to know that they are going? How are we supposed to know how many times they are going to intersect if we have a graph of two polynomial equations?
Yeah, for that you need to solve the polynomial, right? So if you have two polynomials, px and qx, okay, you want to know how many times they are going to intersect, right?
Yes, sir.
So for that you need to solve this polynomial, right? P of x minus q of x is 0. Okay, if you solve this equation, then you will get total number of points at which both the polynomials will intersect.
Okay, sir.
Yeah, so for example, this is suppose x square plus you have 2x plus 3. This is one polynomial. Okay, and you have another polynomial 2x square plus x plus 7, and you want to know at what points this polynomial will intersect. So precisely you need to solve p of x minus q of x equal to 0. So that is basically x square plus 2x plus 3 minus 2x square plus x plus 7 equal to 0. This is a new polynomial, right? You'll get something new.
Minus x minus.
Yeah, so yeah. So this basically you need to solve this polynomial minus x square plus x minus 4 equal to 0. So once you solve, you will get two values of x. Okay. So these two values, this polynomial p of x and q of x will intersect. That's it.
Sir, can you hear me now?
Yeah,
so I have one question. So which is come on June. So consider a polynomial function p of x equal to minus 0.01 x minus 1 into x minus 1 into x minus 2 the whole square.
You are asking me to again drawing the graph.
No, it's not a draw. So in that they have asked they have asked with respect to the relations. It is neither reflexive nor symmetric and not transitive. So since we said
polynomial.
Yes, that is the first question in the June.
Okay, so can you read it out? Yeah, please.
So consider a polynomial function p of x equal to minus 0.01 into x minus 1 into x minus 2 the whole square into x minus 3 the whole square into x minus 4 into x plus 1 into x plus 2 the whole square. So they have given the options as R is neither reflexive nor symmetric nor transitive.
Sorry, I guess you are mixing two questions. Okay, you check it properly. Okay, this is not possible. Okay, so you have a polynomial.
Yeah, this is related to graph, sir.
Yeah, so this is related to graph. I guess you are mixing two different questions. Okay, certainly you have a polynomial, and after that no one will ask whether it is reflexive. You don't have a relation. So how come one can ask you about reflexive? You check it properly. I guess you are mixing two things. Okay, or maybe you don't have the complete paper.
Okay, I written it that time. Sorry.
No. So not possible. Okay, so I'm pretty sure it is not possible. Okay, you might have some different question, and you might have some relation, and after that relation, they might have asked you about what kind of relation. See, when you have a polynomial, hardly they can ask you what is the x. In general, if you see your activity question, what is the question, like number of turning points or maybe y-intercept or something like that. So no one will ask.
So what are the number of turning points?
You try to, I have already explained you two questions. You try to do it accordingly. Okay, so I guess I'll stop the session now. Okay, so
play once functions.
Sorry?
Functions.
Sorry, function. What is doubt? What is your doubt in function?
Sir, I have one doubt in function a symmetric relation, that is
no symmetric relation.
Anti-symmetric and
relation
में sir थोड़ा doubt the solution.
And what is your doubt in anti-symmetry relation? Like you have problem with the definition or what?
Yes, sir. In the definition, sir. Sir, I can't differentiate between anti-symmetric and symmetric.
Okay, let me discuss.
Sir, I have a doubt in the polynomial you have written about.
First, let me complete whatever.
Sure.
Yeah.
Sure.
Okay. So anti-symmetry relation says that so you have anti-symmetry and another is symmetry, right? Symmetry says if A comma B is in R, this should imply that B comma A is also in R, right? This is symmetry. Okay. Anti-symmetry is something different. Okay, it says that if A comma B is in R and B comma A is in R, this should imply that A is equals to B, right? These are two definitions of anti-symmetry. Okay, yes, sir. This is the definition of anti-symmetry and this is the definition of symmetry. Okay, let's take an example. Okay, suppose A.
Anti-symmetric B comma A not belongs to R. It's only anti-symmetric.
Sorry?
Because B comma A also belongs to R.
If A comma B and B comma A in R, that should imply that A is equals to B. Okay, that is the definition. Or there is one, whatever you are saying, that is another definition of anti-symmetry, which is more or less, and this is same as the one that you are saying. Okay.
Okay.
So for example, suppose this is your set 1, 2, 3. Okay. So suppose you take a relation 1, 1, 1, 2, 2, 1. What, so my question is whether R is a symmetry relation or not.
Yes, sir.
This is symmetry relation.
Yes,
Why?
sir.
It is symmetric relation.
Why?
1 comma 1 is there. 1 comma
2
2
comma
is
1
there.
is
2
also
comma 1
there.
is there.
1
A comma B and B comma A also exist.
There. Okay. So my next question is whether R is an anti-symmetry relation or not.
No, sir.
Yeah, correct. Because see, the problem is here. What is the problem? See, you have to check in anti-symmetry relation. What it is saying? If A comma B is in R, okay, and B comma A is in R, this should imply that A is same as B. So here, if you see, this is A comma B is in R, okay, B comma A is in R, but the problem is A is not equal to B, right? Because A is 1, B is 2. So that's why R is symmetry relation, but it's not an anti-symmetry relation. So now, what about this relation? 1 command. Okay, please mute yourself. Okay, so
It is anti-symmetric.
it is anti-symmetry because it's saying anti-symmetry says that if A comma B is in R, B comma A in R, that means A comma A has to be equals to B. So here A comma B is in R, and if I flip it, B comma A is also in R, and at the same time it satisfies the third condition, that is A is equals to B, which is equals to 1. So what about this relation?
It is anti-symmetric.
1
So
comma 2.
The previous one, 1 comma 1 means it is reflexive identity and symmetric, and
No,
then it is
no.
is it a transitive or something?
No. I'm now don't go to all these things.
Okay. Multiple, it is satisfying.
No, okay. So my first question is, so when you joined this session? When you joined this session, like, because
no, in between I got disconnected because of power cut. Just now I have joined.
No, I have discussed about this reflexive relation, symmetry relation, and transitive relation.
Sure, sir. No problem. Yeah, I heard in the beginning. Yes.
Yeah, you
please
can
go
check.
ahead, sir.
So, so let me discuss about this. So here R. So if you take 1, 2, whether this is the anti-symmetry relation.
No, sir.
No, sir.
Why?
There's no B, comma A, sir.
Because A and B are not equal.
No, the problem is, so that is the difference. What is the condition of anti-symmetry? Anti-symmetry says
There is no B, comma A, sir.
there is no B.
A is not equal to B.
No. So the problem, no, the thing is, you are not reading the definition properly. What is the definition says? Definition says if A comma B is in R and B comma A is in R, then
I check A.
Then you need to check whether A and B are equal or not.
Yes, sir.
Okay. So here A comma B is in R, but B comma A is not in R.
Not here.
So so this is fine, but this is not fine. Okay, B comma
Yes.
A is not in R. If B comma A is not in R, then I don't have to check whether A is equals to B or not. Okay, so then this is vacuously anti-symmetry.
Yes, I got it.
Okay, but this is not, R is not symmetry, because symmetry, what is the condition? Symmetry says if A comma A is in R, then you need to check whether B comma A is in R or not. So here A comma B is in R, but B comma A is not in R. Okay, that's why R is anti-symmetry but not symmetry. Okay, fine. Okay, any other doubt?
Yes, sir.
Yes, sir.
Mm-hmm.
So, for
Sir,
example,
suppose
just a minute.
example A.
Just a minute. No. Someone else actually asked me some question.
So, for example, there is a 0 of a polynomial, and that is 0. So, would be considered?
No. Please say say it clearly. I'm not clear what you are saying. Can you repeat your question properly? Hello. Am I audible?
Yes, sir. Yes, sir.
I have a doubt, sir. Can I ask, sir?
Mm-hmm.
Sir, can you explain the difference between the subset and the proper subset, sir?
No, difference between subsets. What is the subset? Subset means it's proper subset means that subset is not equal to the original set. Okay, so when I can say that A is a subset of X, means all the elements of A should be inside X, then only you can say that A is a subset of X. If A is a subset of X, but A is not equal to X, then you say that A is a proper subset of X. Okay, for example, if I take A equal to 1, 2, 3 and X equal to 1, 2, 3, 4, whether A is a subset of X or not?
Yes, sir. Subset.
A is a subset of X, right? Next question is whether A is equals to X or not?
No, sir.
No, sir.
So A is a subset of X, but A is not equal to X. That means A is a proper subset of X. That means A is a proper subset of X. So you just need to check one condition. If A is not equal to X, then you are done. Then A is a proper subset of X. Okay. So that is the only condition you need to check, whether your subset is equal to your original set only. If the subset is not equal to the original set, then your subset is a proper subset.
It's clear, sir. Doubt clear, sir.
Yes. Okay.
Thank you.
Thank
I
you.
have a doubt, sir. Sir, can I ask?
Amit Kumar, yeah.
Yes, sir. We take A equal to 1, 2, 3, and R equal to 1, 1, 2, 2.
Just a minute. 1,
Yes,
2,
sir.
3. R equal to
1, 1,
1, 1,
2, 2,
2, 2,
and 2, 3.
2, 3.
It is reflexive or not, sir?
No, not reflexive.
But sir, in the lecture videos, sir saying it is reflexive, sir.
No, it's
Sorry,
not.
sorry, sir. And also 3, 3, sir. We take also.
Yeah, then it is reflexive.
Oh, okay, sir. Clear.
Yeah.
Sir,
Hmm.
sir,
Hmm.
I have a doubt, sir.
Hmm.
I have a doubt in week 3 quadratic equations.
Hmm.
So I'm just a little bit confused in the concept of roots and intercepts because both of them are lying in the x-axis. So can we use these factorization methods and the
No,
formula
for
minus b by 2a simultaneously?
Factorization method will give you x-intercept, right?
Yeah. Yes.
Yeah. If you factorize a polynomial, you will get the roots, right?
Yes, sir.
So if you have a quadratic equation, so this point is basically it's a root of the polynomial, right?
Yes, sir.
The x coordinate of this point is a root of the polynomial. The x coordinate of this point is a root of the polynomial. So
Yes,
for
sir.
that you need to factorize this, or maybe you can use that formula, which is x equal to minus b plus or minus b square minus 4ac by 2. So if you apply this formula, then you will get this x-intercepts.
Okay, sir. So can we use the x-intercepts and root formula, factorization formula simultaneously?
No, whatever is convenient for you, you can use that. Okay, so both. So if you factorize also, that will give you, if you apply this formula, then it will give you the roots, and from there you can factorize it. Or if you want some direct method to factorize the polynomial, that is also fine.
Okay, sir. So that's my doubt, sir.
So one general doubt, sir. Sir, will we draw any graphs in our exams, sir?
No. You don't need to draw any graphs in the exam.
Okay, sir.
Okay, then I'll stop the session now.
Sir, I have a general doubt, sir.
Okay,
Sir, will be the question related to week 1 to week 4.
Hello.
Yes, sir.
Week
will be the question related to week 1 to 4 or not, sir?
Yeah, what is your syllabus for this exam?
Yes, sir. And it is also related to qualifying exam questions.
Qualify related to means what? Like
it's only the qualifier. It's only the qualifier. Yes.
It's a qualifier exam. The syllabus is from week 1 to 4. That's all.
Okay, sir.
Yeah, someone asked me what is heat and what is heat and trial method? There is nothing called heat and trial method.
Sir, I have doubts.
What is your doubt?
Can you please explain which topic will contain more weightage in the qualifier?
That I don't know. That I don't know. The syllabus is week 1 to 4 and everything is in. Okay. You need to cover all the concepts. Yeah. No, I still don't understand what is heat and trial method. There is nothing called heat and trial method from week 1 to 4.
So maybe they are asking something like how that approach, how we should approach the questions. Like
okay, for that I need to know the question, because
Yes.
So the thing is, heat and trial method actually it's completely different from question to question. Okay, so for a different question you need to know. So the thing is, heat and trial method generally you you generally use it to find the roots of a polynomial. So for that you need to, so in that case you need to put some value and check whether that value will give you 0 or not. For example, you have a polynomial p of x equal to x square minus 1. So you want to find the roots. For that, what you need to do? First you need to start with 0, and once you substitute 0, you are getting minus 1. So that means 0 is not a root. So next you need to go further. So you can try with 1, or you can try with minus 1. So that is a method. So it's depend on the question, like what type of question you are approaching. For different question, you can have different types of method to approach that question.
Excuse me, sir. Sir, if time allows, sir, tomorrow can you take a small session for doubt?
Okay, so I'll ask Vicky, and I'll so when you want me to take that session?
In morning, sir, or like
no, morning I guess I can't.
Morning, sir, 8 to 10 or 10 to 12, something like that.
When you have exam?
On 10, sir.
10
This Sunday.
Sunday. Okay, so probably tomorrow
Sir,
evening also
sir,
fine. Like in
sir,
this time.
So tomorrow evening CT classes are there, sir.
Yes, sir.
Excuse me.
CT revision sessions are there.
Okay,
Excuse me, sir.
Just a minute. Okay, so someone is talking, right? I don't know why you are in so hurry. I'm here for last 3 hours. Okay, so I don't know, but tomorrow I guess it's not possible, because we have to inform the portal team and they have to send you link. So at least I need, suppose if we are going to take a session, then certainly tomorrow morning is not possible. It will take session, and mostly then probably tomorrow similar time around 7 we can take a session. Morning
Okay,
is not.
if it is possible, sir, can you take a session on Saturday?
Yes,
is it
sir,
possible?
yes.
Saturday, don't you think Saturday is too late?
No,
Saturday is too late, but yes, some time constraints are there, sir, because tomorrow we do have on 7 to 9, we do have our sessions of CT.
Okay.
So probably we have to join that as well.
Saturday we can do, sir.
Okay, then I'll talk. I'll plan a session on Saturday. Fine.
Just a small for just doubt clearing. So
Yeah, I understand. From I don't have any problem. Like I'll set up a session on Saturday.
Sir, could you please say about some squared error?
Sir, in case if you are planning on Saturday, maybe in the morning, that means in the first half would be good, sir.
Yeah. Morning, Saturday morning is fine, but tomorrow morning is not fine. That
yes,
is,
sir. No, not tomorrow.
Okay.
Maybe Saturday morning.
Same
Sorry?
problem with me also.
Sir, for that, sir, when we will get the schedule confirmed?
It will confirm the
No,
link is where available, sir.
tomorrow, so don't worry. Like I'll set up. Okay, so you'll get a link.
Okay, sir. Thank you.
It's in a Telegram or Gmail, sir. Link.
No. This mostly on Zoom. Okay.
Calendar, you will find it on calendar.
You will will set up. See, if will not set up, then we'll send you announcement through probably for Gmeet link. Okay, so don't worry about it. You will get the announcement. Okay, don't worry.
Sir, could you please
Thank you,
explain SSE briefly?
SSE. Okay, so SSE. So I guess probably since we have planned a session on Saturday, then probably I'll do it on that. Okay.
Yeah, that's better, sir. Yeah.
Sorry, like I'll do it on the Saturday. I'll explain it properly. Okay. So now, if you ask me, then probably I'll do it in hurry. Okay. So, so you are fine, right? You can attend the session on Saturday.
Yes, sir. We don't have any issues. Yeah.
Yes, sir. Yes, sir. No problem.
Okay. Then I'll set up a session on Saturday. Okay.
Yeah.
Okay.
Thank you so much, sir.
Yeah.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much, sir. Thank you, sir.
Thank you, sir.
Thank you all. Okay.
Thank you, sir. Good night.
Good night.
Good night. Yeah.
Good night, sir.
Good night, sir. Good night, sir. Thank you, sir.
Good night, sir.
Good night.